around the 70 plus or 80 plus companies are recruiting based on value. We are including DRDO, Defense Research Development Organization, or DRDN, Defense Research Development Labs. The computer science people are also having more openings in all over these public sector undertaking companies. Okay. So GATE is not only for doing the post graduation, but also for doing the job in any of the PSUs. And one more important thing is you can do your integrated PhD in IITs or NIT. So if you don't have the valid GATE score, you are not eligible to do PhD. So whenever you do the master's program, in order to do the PhD research work in your concerned field, definitely you need to have a valid GATE score, either in NITs or IIT. So in all these aspects, it is very important. Previously, people have understood that it is very important. Now, also people are thinking again and again. Why? Because by the meantime, you people are running around saying multinational company jobs. The multinational company jobs, they may offer you around 3 to 4 lakhs of rupees as a per annum as a starting salary. But in PSUs, you will be having around 10 lakhs. And it is having exponential growth. Okay. But in multinational companies, you cannot expect that. But even if you want to go for artificial intelligence and the machine learning and all the remaining things, there are also more fluctuations you have to face. Say, for example, if you want to go and study in US or UK by doing the post graduation. Doing post graduation in abroad, it takes only 15 months to 20 or 24 months, not more than that. But in order to get the job and to be settled in that particular country, it will be very difficult. But even the people are going like, okay, and also it takes minimum of 50 lakhs of rupees expenditure and 4 to 5 years of time you have to spend. Okay, so these are the things that you are having before your future. From third year, not only third year, from first year itself, you have to get ready for facing all these competitive exams. So do you know GATE? What is GATE? Graduate Estate in engineering, of engineering, for engineering. Make sure while you are saying about it, because English is also very important, and you are having English also in your GATE syllabus. Okay. Most of the IITians or NITians are unable to get the jobs in public sector undertaking companies as well as even in the multinational companies. Examination or any other business model examination. So that's why they have introduced English also from 2010 onwards. And they also have introduced the general aptitude, which includes simple mathematics or as well as reasoning. Okay. So by your general thinking itself, you can score up to 15 marks. And the rest of 85 marks, which includes engineering mathematics along with the other subjects. Okay. So with those 15, and in engineering mathematics, you are having another 15 marks. And in engineering mathematics, you are having discrete mathematics. You will be calling it as general mathematics and discrete mathematics, but both are combined to be called as engineering mathematics. So topics are linear algebra, probability and statistics, calculus, ordinary calculus. Okay, because the other branch people are also having vector calculus. We don't have a vector calculus. And next, graph theory, combinatorics, set theory and algebra, propositional calculus. Propositional calculus is more related to your computers. And but the computer science, doing any of the problem in order to solve any of the problem of the computer science, you need all these things. if you don't have the maths, you will not get the final destination or the answer, or your program will not become. Okay, so that is very much required. Even one of the students who did his BTech in Vijayawada Siddhartha, completed BTech in 2007 and went to US. And he was there in US for more than, I think, up to 21. Now also he's there in US. Recently, before this COVID period, this AI, artificial intelligence, is ruling the entire technology in the software area. So he wants to enter into the artificial intelligence. That's why he has to learn some of the basics of the math. Without mathematics, you can't do the programming. Okay, everything is like. Now I know all these topics. The most important thing, whatever the field that it is, whether it is business or a medical field or whatever it may be. So definitely you need to apply the probability. At the start of the discussion with the probability and stats. And you write the probability. Yeah. There. Okay. Before we get in, let me write some of the definitions. In order to discuss the definition of the probability, we need three important things. One is exhaustive event, second is mutually exclusive, third is equally likely events. All the three seems to be same, but you need to understand the difference between them. Otherwise, you can't get anything. What are exhaustive events? Write down exhaustive events. EXHAUSTIVE. I can write with my finger, but it hurts. I'm not responsible. Exhaustive event. EXHAU. Have you written? EXH. Exhaustive. STIVE. Exhaustive events. What are exhaustive events? See, when I outside point, you're going to get either head or tail. Okay, only two possible outcomes. So again, when we are throwing cubical fate dice, phase 1, phase 2, phase 3, phase 4, phase 5, phase 6. And 100 people are writing the examination. What are exhaustive events? Getting qualifying that examination. Everybody. Everyone are having equal chance. Everyone can qualify that exam. Okay. So when a baby is going to take birth, what are exhaustive events? Is a baby girl or no third gender? Okay, that is very sure about. Because at the time of birth, they will write only two things. But at the time of employment, it is their choice. Either one third gender or fourth gender, whatever they be, they can write. Okay, now government is allowing. They are giving reservations. But at the time of birth, only two persons. What are those? Either baby girl or baby boy. Okay, so these are exhaustive. What are exhaustive? All possible outcomes in an experiment. All possible outcomes. All possible outcomes. All possible outcomes. All possible outcomes in an experiment are known as exhaustive events. Now set off all exhaustive events. What are set off all exhaustive events? Sample space. Okay, madam. Set off all exhaustive events is known as sample space. Sample space. Next, mutually exclusive events. Mutually exclusive events. You may be having the habit of viewing the news channels. Say yes or no. Don't fluff it for me. For the sake of impressing me, don't say the things. Okay. It is your life, you have to live and you have to live. And you need to live for yourself, not for any others. Am I right? To some extent, after a few days or few years, you will be living for some people, that is your family. And next, for your kids. Okay, only that's enough. Don't live for anybody else. Now you tell me frankly, do you have the habit of viewing the news channels? No. Oh, very frank. That's good. So you can get the visa very in the first attempt itself. The thing is, the frankness is required, but you need to have the habit of viewing the news channels. Okay. So what type of news channels if you are having the habit? So you need to have the habit of viewing the news channels, particularly like the BBC or CNN. CNN is US based international news channel and BBC is UK based. So both will give you much vocabulary and the preferred language where you're going to work in the world. Okay. So now everything is becoming global. So you need to learn the things only through English medium and you need to work and you need to give the inputs to the world only through this language. In order to develop it, you need to have the habit of it. The news channels, there are some few important things. When some news is broadcasting, there used to be CNN exclusive or TV9 exclusive, NTV exclusive. You might be observing about. What is the meaning of exclusiveness? Yes? Just say something. So when you are trying to speak something or say something, then your learning capabilities will be increased. Okay, later on someone will correct it. Don't bother about it. పుట్టుకతో అన్నది మేధావులుగా అవుతారా నాకు థ్యాంక్స్ తెలుసా ఆయనకి ఎక్కువ అంటే 5 years వరకు సరిగ్గా మాట రాలేదు మాత్రాన్ని ఆయన ఇదైపోయాడు అర్థమైనా మీరు కనీసం మాట్లాడాలి వాట్ ఎవర్ యూ నో జస్ట్ ఎక్స్ప్రెస్ ఇట్ yes or no yes tell me now what is the meaning of exclusiveness exclusiveness. At that time, that particular news item being broadcasted in that news channel only. You remember once again, at that time is important. Time or trial. Particularly in probability, we use the word trial. At that time or trial, that particular news item, that event is going to happen in that news channel only. 3 important things are. Those 3 are very important. Okay. So here exclusive means in the trial that event is going to occur in that one only, in that news channel only. Okay. One more thing. If you toss a coin, head appears. Will you get to take at the same time? No. Only head appears. So the occurrence of head prevents the happening of tail. Okay, when a baby girl is born in a single baby birth, so when a baby girl is born, it prevents the happening of boy. Okay, when you toss a cubical fake dice, if phase 1 turns up, it prevents the happening of all the remaining 5 phases. Okay. In a running race, if 10 candidates are participating in a running race, if one candidate wins the gold medal, what you can say? The winning chance of that gold medal by particular candidate prevents the others to win that gold medal. So one is winning, remaining are losing. Happening of one prevents the happening of other. when in that event only, in that tribe only, in that tribe only. The happening of one event prevents the happening of all other events in that tribe in an next domain. Such an events are known as mutually exclusive. Mutually means when you are comparing with the other, you have to use the word. Okay, right. The happening of an event in an next domain. The happening of an event in an experiment. An experiment prevents the happening of all other events in that tribe. Such events are known as mutually exclusive events. Mutually exclusive events. Next. Equally likely events. What are equally likely events? What are equally likely events? Suppose you are topper in intermediate. Will you be the topper in BTech? No. Why you are saying no? You have to say yes at least. Even if you are not getting the top rank, you have to say at least yes. Will you be the topper in the gate? Oh yes. Again you are saying yes. No, this is not possible. Okay. So you cannot say every time, whatever examination that you are writing, every time you are all the people who are writing the exam, all are having equal chances of getting top rank. Okay. So if you are topper in intermediate, it doesn't matter. Next, BTech and engineering service or otherwise examination, you will be top. It doesn't matter. But everybody are having equal chances of occurring. Suppose I'm tossing a coin now. If I'm getting head now, will it be the head for the next side? Will it be the tail for the next side? You cannot estimate the next right. Okay, the next one maybe either head or tail. All are having equal chances of occurrence. So what you can say? Equally likely events. What does it mean? The happening of one event in a tribe doesn't affect the happening of the events in another tribe. It doesn't affect. If you are topper, it doesn't affect the next examination result. The next examination result is not going to be affected by the previous result. Okay, such events are known as equally likely events. Okay, right now. Equally likely events. If the happening of an event in a tribe doesn't affect the happening of the events in another tribe. Happening of the events in another tribe. In an experiment. In an experiment. That is all the events in an experiment. All the events in an experiment That is, all the events in an experiment are having equal chances of occurrence. Equal chances of occurrence. And events are known as equally likely events. Example. In tossing a coin, the events head, tail are exhaustive, mutually exclusive, and equally likely events. Exhaustive, mutually exclusive, and equally likely events. Second one, we are going to do the problems based on this and these kind of problems. Asked in the previous grade examinations, phone number. That's why I'm giving those only as an example. Okay, right next. In tossing a cubical fate dice. Cubical fate dice. Phase 1 to phase 6. Phase 1 to phase 6 are phase 1 to phase 6 are yes, you can write all the three. Exhaustive, mutually exclusive, and equally likely. Exhaustive, mutually exclusive, and equally likely. Right. So let you write the definition of the probability. If there are n number of if there are n number of exhaustive, mutually exclusive, and equally likely events, an event capital A may occur. An event capital A may occur for M, small m for IIT Mumbai or IIT Madras. Actually, it is not Mumbai, IIT Bombay is this. Okay, IIT Madras, right? So, an event capital A may occur M number of times. Small m number of times. Small m number of times. Then the probability of happening of event capital A, the probability of happening of capital A, the probability of happening of event capital A, denoted by P of A, P of A is equal to total number of favorable events divided by total number of exhaustive events. Total number of favorable events by total number of exhaustive events. By E. F for favorable, E for exhaustive. Among these two, which is greater, which is less? Favorable is more than exhaustive, more than favorable. Exhaustive is why this is equals to M by N. And it is clear M is always less than or equal to. We keep on giving the numbering for all students from A, B, C, D up to Z. M will have less number than the of N. Okay. So M by N. M will be always less than or equal to N. Both M and N must be positivities. Do you remember? Both must be positivities. Do you remember? Right. So this is the definition of probability of happening of an event. Now, what is the probability of not happening the same event? The probability of not happening event capital A is equal to, we may give three different types of notations, P of A complement or P of A bar or P of A dash. So now you tell me, if A occurs for M times of N, A doesn't occur for how many times? See, A is occurring for M out of N. Okay. Now A will not happen how many times? A will not happen N minus M times out of N. So this is equal to 1 minus M by N. This is equals to 1 minus probability of happening A. So from this you can write probability of happening of any event plus probability of not happening the same event is always equals to 1. Okay. So when you are saying a person is existing, so whether he may be alive or dead. Am I right or not? మనిషి ఉన్నాడు అంటే మనిషి అని చెప్పాక మనిషి ఉన్నాడు అంటే ఏంటి అర్థం? బ్రతికంగా ఉండాలా? చచ్చగా ఓకే. Am I right or not? So you cannot assume that a person who is going to take birth పుట్టబోయే వాడు ఉన్నాడు అని అనుకుంటారా? So that is not scientifically proven. Okay. So when you are saying something, A means alive, happening. A complement means not alive. Sum of both must be equals to 1 life. The 1 life always includes the person is alive plus not alive, dead. Okay, so everybody has to accept the truth. Is it clear?
Yes, sir.
Right, next. The probability of impossible event. When you say that a dead person can walk, that a dead person can jump, that a dead person can play the game, what kind of event it is? It is impossible. Am I right or not? A dead person walking, or a dead person playing, a dead person is laughing, everything is nothing but impossible. What is the probability of impossible event? 0. Right. Probability of impossible. Probability of impossible event is equal to 0. So you're sure about that the probability can never be negative. You cannot say that the probability is less than 0. Okay. Now next, the probability of certain event probability of certain event is equal. Certain means rising of sun is S-U-N, not S-O-N. Okay, rising of sun from one direction, from east, every day. Is it true or not? Every day, sun, S-U-N, sun rises from one direction. Is it true?
Yes, sir.
Who said it is yes? You are a computer science student, you are a technical guy, sun never rises. Actually, sun is static. And the earth is moving. The earth moves like this, it seems to be sun is rising. Okay, you can say, as per this content is concerned. Okay, sun rises from one direction that is named as east. Whether it is cloudy, rainy, or mist, or whatever it may be, whether you are awakened at that time or not, sun rises from one direction in India particularly, because there are some countries in the world where sun never sets and sun never rises. What is that country? Yes, yes. Okay, good. It's not in basic. Okay, that's one. So the probability of certain event is always one. Is always one. Is always one. Some people sometimes used to say 500% I will do that work. Maybe you're going to face when you are becoming family, your spouse is going to give you some kind of promises. 500% I will do that work. Okay. So 500% is what is the probability? 500 by 100. What is that? 5. Is it true? Certain means maximum probability will be up to only 1. So what is the remaining percentage? Your spouse is bluffing you, the remaining 400%. So you cannot believe such kind of. Even 120%, 110% also not correct. So even if somebody says some promises like only up to 100% is allowed. Okay. So being a probability knowing person, if somebody says for 50% I will do that work, then you can laugh. And then you can smile. Then you can understand what he is doing or what they are doing. Right? So the probability can never exceed 1. Lies always in between 0 and 1. Okay? Right now. 0 less than or equal to probability of happening of any event less than or equal to 1. Okay. Right. In order to do the problems based on the definition of the probability, we need to know 2 important things. One is permutation. The next one is combination. So, when calculating the total number of exact events as well as the favorable events, we need to know the difference between permutation and combination. Now you tell me what is permutation and what is combination. Permutation means where arrangement. What is combination? Why selection? You need to know the thing, both the things, just by using the word only arrangement. Permutation is arrangement. Okay. So what type of arrangement it is? Yes. Right. The words also left. Come on. Yes, it is an arrangement with respect to that's enough simple. With respect to order. Say for example, Now suppose if you have given 3 elements A, B, C, by taking 2 at a time, how many arrangements you can write with order? Now 2 at a time I am saying A, B, B, A, B, C, C, B, A, C, C, A. How many? 6 arrangements with respect to order. A, C, C, A both are different. Say for example 1, 2, 2, 1. 1, 2 is 12, 2, 1 is 1. Both have different meaning. In the same manner, in certain cases, if the arrangement is done with respect to there is nothing but random. Permutations are the arrangements. The arrangements with respect to order. With respect to order. With respect to order. The given 3 elements A, B, C. For the given 3 elements A, B, C. 3 elements A, comma, B, comma, C. Taking 2 at a time. Taking 2 you can write 6 permutations. You can write 6 permutations. A, B, B, A, B, C, C, B, A, C, C, A. Nothing but 6. So this is equals to, actually, permutation is given by B. You may write the total given elements are 3. P for permutation, 2 taken at a time. 3P2. 3P2. Okay. You may write this as P32 also. This is equals to, what is the definition for this? 3 factorial by 3 minus 2 factorial. This is equals to 3 into 1 equals to 6. Okay. Now do you have 6 permutations or not? Right. In general, right now, in general, the number of permutations we can write. In general, number of permutations we can write. Number of permutations we can write by taking R at a time, R, small r at a time, small r at a time, out of the given n elements, out of the given n elements is equal to NPR. NPR equals to PNR is equal to n factorial by n minus r prime. Here you need to remember n comma r are positive integers such that n always greater than or equal to r. Any total given elements, r is we are choosing. Out of n elements, we can choose maximum n elements at a time. Okay, not more than that. That's why n must be greater than or equal to n must be greater than or equal to r. Okay, next. What is combination? P for permutation. What is combination? Combination. This is permutation. What is combination? If you are saying NCR, then you are not writing gate exam. You need to know the concept, meaning of it. మనం ఏం చేస్తున్నామో దాని అర్థం పూర్తిగా తెలుసుకుంటే మనం ఏం చేస్తాం హైయర్ స్టడీస్కి వెళ్ళాలి. అంతేగాని ఆ కాంబినేషన్ అంటే సి అంటే కాంబినేషన్ that's not the way of learning. Okay, so what is combination? It's a clearly combination. It is arrangement with respect to order. You can say similar technique. What is that similar technique? Combination is also an arrangement, not selection. But you may use the word selection for a specific arrangement. That's enough. It is also an arrangement, yes, where order is not required. Suppose 4 people are required to be selected for a quiz name for your class. Okay. I select someone first, someone next, someone next, someone next. Are selected. Whoever is sitting in that table or on those chairs in a row, it doesn't make sense. Am I right? But here in permutation, it makes sense. Order makes sense. But here order is not required. That is combination. Okay, what are the combinations that you can write? What are the given three A, B, C by taking 29? What are the combinations? A, B, B, C. That's enough. Only three. Okay. A, B, B, A. Both to be considered as one combination. Right on. The arrangements, irrespective of order. The arrangements, irrespective of order, are known as combination. Given three elements A, B, C, taking two at a time. Now given elements A, B, C. Three elements A, B, C, taking two at a time. The combinations that we can write are A, B, B, C, A, C. Okay, so this you can write 3C2 or C 32. This may be written as 3 factorial by 3 minus 2 factorial into 2 factorial equals to 3 into 2 factorial by 1 factorial into 2 factorial. Both gets cancelled is equal to 3. Okay. In general, the combinations that we can write, by taking R at a time, small r at a time, out of given n elements, denoted by NCR is equal to CNR is equal to, yes, what is that? N factorial by minus R factorial into
R factorial.
here also n comma r are positive integers such that n greater than or equal to r. Okay, right. So mostly we are using this. Now, let me do some of the problems based on this. I have some of the problems. What is the probability of getting 53 Sundays? 53 Sundays in a leap year. So whatever I am writing on the don't copy it. Whatever I am saying, you just write it and that one, then you can copy. Probability of getting 53 Sundays or happening 53 Sundays in a leap year. Okay. So based on this, almost 2 to 3 times you got the question in the gate examination. Huh? Tell me now. In leap year, how many days you are having? So if you consider 366 as number of exhaustive events, then several kinds of combinations are required in order to write favorable events. In order to write the favorable events, several combinations are required. But in order to synchronize or minimize the problem, you can write this in this manner. Leap year means 366 days. This you can write it as 52 weeks plus. Whether it is leap year or non-leap year, definitely you are going to have 52 weeks. So we need to discuss about these remaining 2 days. What are these remaining 2 days? What are these remaining 2 days? Speak out. Those 2 days may be Sunday, Monday, right now. Monday, Tuesday. Tuesday, Wednesday. Wednesday, Thursday, Friday, next. How many possibilities for those remaining 2 days? How many possibilities for those remaining 2 days? What are possible outcomes? I'm saying about the exhaustive. How many? 7 are there. So number of exhaustive events are 7. Favorable? What are those 2?
Sunday, Saturday, Sunday.
Okay. Why writing these possible outcomes? You cannot write Monday, Thursday.
Because
What you will do in the remaining Tuesday and Wednesday? You cannot skip the days. Okay. So you have to follow the order. That's enough. While writing those days, Monday, Tuesday, Wednesday, Thursday, that manner only you need to. So in such a way, for those 2 remaining days, how many possibilities? 7. 7 possible outcomes. That for 52 weeks is common. What are favorable? Either Sunday, Monday or
Saturday, Sunday.
the answer is 2 now. 2 by 7. 2 by 7. What is probability of getting 52 Sundays in a leap year? Okay. First one was asked once in the previous year. Once it was asked like Saturdays. The answer will be same 2 by 7. Okay. If it is leap year, what is the probability of getting 52 Sundays? Tell me the answer. A similar one. You are right. You are not writing. So, ఏ క్లాస్ లో ఉన్నప్పుడు అడిగిన వాటిని ఆన్సర్ చేయాలా, రాస్తూ ఉండాలా, మీ బ్రెయిన్ కూడా షార్ప్ గా వర్క్ చేయాలి. ఇది చేయలేదు అనుకోండి, అట్లా చూస్తూ ఉండకూడదు. నేనేం ప్రెసిడెంట్ ఆఫ్ యునైటెడ్ స్టేట్స్ ఆఫ్ అమెరికా కాదు. ఇక్కడ ప్రెస్ మీట్ పెడతా ఉంటే ఇంపార్టెంట్ పాయింట్స్ రాసుకున్న తర్వాత మీరు ఎస్ఏ రాయండి. ఓకే, మొత్తం రాయండి. ఓకేనా, రైట్, మొత్తం రాయండి. What is the probability of getting 52 Sundays in a leap year? 52 Sundays in a leap year. You have to say the answer. Leap year, same 366 days, 52 weeks, and 2 days remaining. Tell me now the answer. 5 by 8. Why you don't like this? 52, so say for example, you are having 100 rupees. I am asking you a question, do you have 10 rupees? What is your answer? I am not asking 10 rupees, no. I am asking you, do you have 10 rupees? Say yes or no.
Yes.
Yes, okay. So already there are 53 Sundays with 5 by 7 or some 2 by 7. Okay. Whether it is leap year or non-leap year, already you are having 52 weeks. Okay, 52 weeks means in every week you are having Sunday. So 52 Sundays are already available. In addition, 2 by 7 probability, you are having 53rd Sunday. So do you have 52 Sundays or not?
Yes.
So is it a certain event or not? Then what is probability of certain event? 1. Whether it is leap year or non-leap year, definitely you are having 52 weeks. So 52 Sundays are available. So what is the answer? It is certain event. Okay. Right? Help me answer to the next question. What is the probability of getting 52 Sundays only in a leap year? 52 Sundays only. Fifty-two Sundays only in a leap year. If I ask you a question, do you have 10 rupees only? If you are having 100 rupees, what is the answer? 0. Then you have 10 rupees only means, what is your answer? 52 Sundays only in a leap year. That means, listen, we have 7 outcomes for the remaining 2 days. Okay, those out of those 7 outcomes, what are not required? The possibility of getting 53rd Sunday is not required. What is not required? This one and this one. Both are not required. So what is the answer? If only or exactly is asked, your answer will be different. Who said 5 by 7 previously? You said, so I am not going to disappoint. I have given a question which relates with your, which is equal to your answer. Okay, so that word only, exactly also differs a lot. Okay, even, sometimes, preserve, also differs the answer. Okay, so while doing the problem, while reading the problem, first you need to observe it. In probability, read the problem at least twice. You understand that one. Then within a minute you can do the answer. And one more important thing is, in GATE examination you are having negative marks. Okay? So multiple choice questions. For 1 mark, there is -1/3 for negative answer. For 2 mark questions, -2/3 for 2 mark negative answer. Okay, there are numerically answered questions. For them, no negative mark. Okay, but in JEE, even from numerically outside also,
Negative.
negative marks, but in GATE it is not. Right? That is the difference. Clear? And still more, I want to give you 3 more questions. What is the probability of getting 53 Sundays in a non-leap year? In a non-leap year, One, wait, make it wait. How many days are there in a non-leap year? 365, yes. How many weeks?
52 weeks.
52 weeks plus
1 day.
1 day is remaining. We need to discuss about that remaining day. What is that remaining day? That may be Sunday, Monday,
1 by
Tuesday.
7.
Yes.
1 by 7.
Totally how many are there? 7 possibilities. So that 53rd Sunday comes.
1 by
Only with one favorable thing. What is that?
7.
Next. The probability of getting 52 Sundays in a non-leap year. 52 Sundays in a non-leap year.
1 7.
No? You are following the sequence. It is in the sequence.
1 7.
52 Sundays in a non-leap year. Okay. I said already clearly 52 weeks. So definitely you will get
1 7.
52 Sundays. In a non-leap year. 52 Sundays exactly in a non-leap year. Yes? 6 by exactly, because 53rd is not required. We need to write only the possibility of getting 52 exact. 6. Okay. This was asked previously, and in that manner, we may write this kind of sequence of questions. Is it clear? Right, next. We'll discuss. Given in the previous example, but some of the different types of problems we discussed. Right? Right. A fair coin is tossed. A fair coin is tossed twice. Fair. A fair coin is tossed twice. Fair coin. Fair. Do you know what is fair? Fair coin. Say yes or no. What is fair coin? If you know about it, then you have to say something about it. You're not saying anything. Do you know Old Sholay movie? Old Sholay. You heard about it? Oh. Do you know Gabbar Singh? No, you know everything. Gabbar Singh. Actually, Gabbar Singh was a character of a villain in Old Sholay movie. In Old Sholay movie, there were 2 friends, Amitabh Bachchan and Dharmendra. Both were supposed to protect a village from the a group of robbers. So the entire robbery team headed by this person. Who is that? Your present hero Gabbar Singh was villain in that Old show. Okay. So that Gabbar Singh, he was a villain and he used to rob the entire village, his group of people. వాళ్ళందరినీ తీసుకొని వచ్చేసి అటాక్ చేసి వాళ్ళ దగ్గర దోచుకొని వెళ్ళిపోతాం. సరే దోచుకొని వెళ్ళిపోయేటప్పుడు వీళ్ళకి షెల్టర్ లేదు. అమితాబ్ బచ్చన్కి ధర్మేంద్ర తెలుసా? తెలియదు. ఎవరు చెప్పాలి మీకు? పోనీ నాకు తెలుసా? తెలియదు. వాళ్ళ గురించి అవసరం. రైట్. ధర్మేంద్రకి అమితాబ్కి మంచి స్నేహం ఉంటుంది. వాళ్ళు ఈ ఈ బందిపోట్లు పుట్టాలని ప్రతిఘటిస్తూ ఉంటారు. ఓకే, వాళ్ళ దగ్గర డబుల్ బ్యారల్ గన్స్ రెండే ఉంటాయి, ఫ్యూ కౌంటర్ బుల్లెట్స్ ఇస్తే. సో వాటితోనే వాళ్ళు ప్రతిఘటించాలి. ఈ బుల్లెట్స్ కూడా షార్ట్ అయిపోతుంది. వాళ్ళు వచ్చేస్తారు, అటాక్ చేస్తూ ఉంటారు. అప్పుడు అమితాబ్ బచ్చన్ ఒక పాయింట్ ఇస్తారు. పాయింట్ వేసి టాస్ చేస్తారు. ఆయన ఎప్పుడు టాస్ చేస్తున్నారు కానీ he used to choose only head. Okay, so saying that the one who wins the toss will face them first and the other one will support him but by hiding. సో దాకొని అతన్ని ఇతను కవర్ చేస్తూ ఉంటారు. అది అంటే యుద్ధం చేసేటప్పుడు కానీ ఫైటింగ్ చేస్తున్నప్పుడు ఎన్సీసీ వాళ్ళు ఎవరు ఉన్నారా మీరు? మీకు తెలిసిన షూటింగ్ ఎట్లా చేస్తారు? కొంతమంది ఫైట్ చేస్తారు, కొంతమంది కవర్ అప్ చేస్తారు. అంటే వెనకాల ఉండి సపోర్ట్ చేస్తూ ఉంటారు. సో అప్పుడు అమితాబ్ బచ్చన్ ఏం చేస్తాడు అంటే తన ఫ్రెండ్ మీద ఉన్నటువంటి అఫెక్షన్ తో ఆయన హెడ్ చూస్ చేసుకుంటాడు. ఎప్పుడు కాయిన్ టాస్ చేస్తాడు, హెడ్ వస్తుంది, ఈయన ఫైట్ చేస్తూ ఉంటాడు. ఈయన దగ్గర బుల్లెట్స్ ఉంటుంది. సో ఈయన వెళ్తాడు, వెళ్ళగానే వాడు కాల్ చేస్తే చచ్చిపోతుంది. అనుకున్న తర్వాత అతను కాయిన్ పడుతుంది. Then Dharmendra has seen that one, the coin, and observed that both the sides are heads on. So what kind of coin it is? Unfair coin. You may say unfair or biased coin. No, not unbiased. Unbiased. Biased అంటే పక్షపాతము. Unbiased అంటే పక్షపాతం లేకుండా. Okay na? So fair means or unbiased means both are same, and both means both the sides are having different entities. Do repeat. Okay, పెట్టుకోవాల్సింది గబ్బర్ సింగ్ ఓల్డ్ షోలే కాదు. Fair coin means both sides are having different entities. One is same, the other one is head. Okay. Unfair means both are having same thing. That's okay, na? So what I said, a fair coin is tossed twice, and observe that at least, and observe that at least one head turns up, and observe that at least one head turns up. One head turns up. One head turns up. What is the probability? What is the probability that both the tosses were head? What is the probability that both the tosses were heads? What is the probability that both the tosses were heads? So I'm giving you the options. 1/3, 1/2, 1/4, 2/3. Yes. Just speak out. You can try. 1/2. Say, listen. When a fair coin is tossed once, the possible outcomes are head, comma, head. It is 2 are two ones. What are possible outcomes? 2 power 2. What are those? Head, head, tail, tail, head, tail. How many? 4. If it is tossed for n times, what are possible outcomes? 2 power n. 2 power n. 2 remember, right? Now, actually, if one coin tossed for 2 times or 2 coins tossed for 1 time, the possible outcomes or the number of exhaustive events are 4 only. But in that question, it is observed that what is observed? Please observe that at least one head turns up. So what are possible outcomes now? Oh, at least one head. In then there is no head. Actually, if that word it is observed that is not given. If the word it is observed that at least one head turns up is not given. Number of exhaustive events will be events are reduced to 3 only. Now what is the number of what are number of exhaustive events? Required probability number of exhaustive events are 3 only, not 4. Because it observed that at least one head turns up. Now what is the probability that both the tosses are heads? Both the tosses are heads. Both the tosses are heads comes only. That is answer. Right on. Both the tosses are heads comes only once. Out of those, 3 favorable, 3 exhaustive events. So if you won't consider that condition, it is observed that at least one head comes up, then you may be probably writing the exhaustive events as 4. Write the answer as 1/4, which is not correct. Based on that condition, number of exhaustive events were reduced. Next, another problem. Point is tossed continuously. A paid coin is tossed. All the questions which are explained in the state exam and also other competitive exam. Right. A paid coin is tossed continuously. Then what is the probability? What is the probability that what is the probability that the fourth head turns up in 10th toss. Fourth head turns up in 10th toss. So I'm giving 0.082. Right. Yes. You have given a fair coin. No need to explain it again. Fairness means both sides are having different endings. One is head, the other one is. What is probability of getting head then? If it is fair, probability of getting head is. Probability of getting tail is 1/2. Right, good. Because both are equally likely, and it is fair coin. Now coin is continuously tossing. You need to get the fourth head in 10th toss means in the first 9 tosses, how many heads you need to get?
3.
Right after. We need to get 3 heads in first 9 tosses. In first 9 tosses. So we are choosing 3 out of 9. Out of 9, we are choosing 3. Okay, what are those 3? Those 3 must be heads. So 1/2 for first head, and another 1/2 for, and another 1/2 for third head. Okay, and whenever n sounds multiplication, whenever r or r sounds, you have to write additions. Or r for addition and for to remember this throughout the entire discussion. Next, not only this, if 3 times you are getting head, how many times you will get tail? 6 times. For each time, tail probability is 1/2 whole power 6. And this is happened in first 9 tries or tosses. Okay. Now again, for the 10th time, you need to get fourth head. That is again head. Fourth head comes with again 1/2 problem. Okay. So this is equals to 9C3 by 2 power 10. What is 9C3? 9 into 8 into 7 by 3 into 2 into 1 by 10/24. To simplify this, make it quick fast. 3, 4, 12 into 7, 84 by 10/24. Can you say the value of it? You have to say that. 0.082. Sometimes if the options were not given, in case of numerically answered questions, you are supposed to write the value in terms of decimals. For numerically answered questions, the answer will never be negative. You will have only positive value. That also you need to write in terms of decimals, corrected to minimum 2 decimals. Okay, corrected to minimum 2 decimals. That is very important. Is it clear? Right, next another question. Right. A deck of 5 cards numbered. A deck. B is in a deck. A deck of 5 cards. Deck of 5 cards numbered. Numbered 1 to 5, shuffled thoroughly. 1 to 5, 1, 2, 3, 4, 5, shuffled thoroughly. Do you know the shuffling of cards? Oh, shuffling. You are practicing. No. 1 to 5, shuffle thoroughly. And 2 cards are drawn at random. 2 cards. 2 cards are drawn at random. At random. One at a time. One at a time. One at a time. Without replacement. Without replacement. Without replacement. Then what is the probability? Then what is the probability? What is the probability that the first taken card is exactly one higher than the second? Exactly one higher than the second. One higher than the second. Okay. Now I'm giving you the options. You have given 5 cards number 1 to 5. Shuffle thoroughly. Next, 2 cards are taken one at a time. What is the meaning of 2 cards are taken one at a time? I have taken a card, kept aside. It is not replaced. It is also written, not replaced. And then take another card. Now you have to find the probability that the first card is exactly only one higher, not higher. Exactly one higher. Okay, that is also very important. Exactly one higher than the second. That comes with the favorable events. Now you tell me how many exhaustive events are there? How many exhaustive events in this required probability? My first card, 5 are there. I have chosen one. One chosen out of 5. And what is the meaning of that? Multiplication, not plus. How many cards left? How many left? 4 left. Now the first taken is replaced or not replaced? Yes, not replaced. 4 left. Again choose 1. This is about number of exhaustive events. This is about, okay, what are favorable events? Favorable. What are those? Tell me, what are those? Good. 3, 2, next. 4, 3, 5. Anything else? No other question. Only 4 favorable. This is number of favorable. 4 gets cancelled. The answer is 1 by 5. Okay. There is a possibility of getting confused. While writing or choosing the answer. Okay. So I'll explain how you are going to get confused. Right, note number one. Note number one. In the above problem, if both the cards are drawn at, if the both the cards are drawn, both the cards are drawn simultaneously. Simultaneously means same time. Like selected two cards. It may be used simultaneously or selected both together or taken at a time. You may use all these three. Okay, anyone is said simultaneously. Then what is the probability that the first card is one higher than the second? First card is one higher than the first card is one higher than the second. Just tell me, in this case, what is the required probability? How many cards are there? 5. How many were chosen? 2 chosen at the same time. Okay. 5 C2. It is nothing but the combination. Right? Now what are favorable events? Same thing. So how many favorable events are there? So 4 by 5 C2 is 5 into 4 by 2 into 1. So 2 times and 2 times. This is 2 by 5. Okay. See, listen. Instead of writing 5C1 into 4C1, instead of writing 5C1 into 4C1, what will happen? Huh? Instead of writing this one, if you have written 5C2, that means one taken at a time without replacement. If it is not considered, if you have considered both together taken, then the answer will be different. Okay, the mark will become negative, and that will make you to university seat instead of NIT, or NIT instead of IIT, or IIT instead of PSC job. Right? That simple single word differs a lot. It will change your fate. Am I right? Next. If both one card is taken at a time with replacement, what will happen? Note number 2. Note number 2. In the above given problem, above given problem, the above given problem, if the cards are drawn one at a time, cards are drawn one at a time, one at a time with replacement, with replacement. With replacement. And what is the probability? What is the probability that the first taken is? That the first taken is exactly one higher than the second. First taken is exactly one higher than the second. Yes. Just tell me what is the answer. What was that one? What's the answer? What is the answer? See, the events were cards were selected. 5C1. First card taken with the 5C1. And again, second one. Second. First taken is replace or not replace? Replace means again 5C1. What are the favorable events? So what is the answer? 4 by 20. So if you are not considering the replacement or without replacement, answer will be different. Okay. If you are not considering one at a time, then answer will be different. Okay. So with all such possibilities, that question was asked. This was also asked in the previous GATE exam. Okay. We'll discuss some problems related with the dice. Dice. Okay. Right now. A cubical fake dice. A cubical fake dice is rolled once. Is rolled once. If 1, 2, 3 turns up. If 1, 2, 3 turns up. 1, 2, 3 turns up, then 1, 2, 3 turns up, then the dice is rolled again. And the dice is rolled again. Rolled again. Again means only for second time. It's not again and again. Only rolled for the second time. That is the meaning of it. Okay. Then what is the probability? Then what is the probability that the sum of the sum of the scores turn up is at least 6. Is at least sum of the scores turn up is at least 6. At least 6. Let me give you the options. 1 by 2, 1 by 3, 1 by 4, 10 by 21. Yes. See, if it is a paid dice, how many faces are there? All are having equal chances of turning up or equal chances of occurrence. That means phase 1 is having probability 1/6. Phase 2 1/6. Phase 3 1/6. If it is a paid dice, do remember if it is a paid dice, all have same probability of occurrence. Okay. Next, if one turns up, it is rolled again. If two turns up, rolled again. Three turns up, rolled again. So if one turns up, again it is rolled, means what are possible outcomes in that case? 1, 1, 1, 2, 1, 3, good, good, 1, 6. 2 means 2, 1, 2, 2, 2, 3. Next, 2, 6. Next, 3, 1, 3, 2. Next, 3, 6. If 4 turns up, is it allowed for next one? Is it given in the problem? So then why you are saying 4, 1, 4, 2, 4, 6? If 4 turns up, okay, there is no second toss. You have to keep it 4 hits only. That's enough. If 5 turns up, 5 only. That's enough. If 6 turns up, that's enough. Okay. Now count how many possible outcomes are there. Count how many possible outcomes are there. Huh? Possible outcomes. I'm asking you possible outcomes. You are saying 18. You are unable to count the things which I have written on the board. Count 1, 2, 3, 4, 5, 6. 19, 20. Possible outcomes are 21. So required probability equals to possible outcomes are what are favorable? At least 6. Some. Are you getting 6 points or not here? At least 6 or not? 1, 5, 1, 6. You are getting minimum 6, right? Next, 2, 4, 2, 5, 2, 6. Are you getting at least 6 or not? Say yes or no. Next, 3, 3, 3, 4, 3, 5, 3, 6. At least 6 or not? Next, do you have any other possibility? What is that? So how many? What is the answer? 10 by. That's it. Actually, if that condition, what is that condition? When 1, 2, 3 turns up, again the dice is thrown. If that condition is not given, if the die is thrown 2 times, or 2 dice were thrown 1 time, 2 dice were thrown 1 time. How many possible outcomes are there? 36. Total number of exhaustive events are 6 squared. 36. If one single dice for 2 times or 2 dice for 1 time, how many possible outcomes? 6 squared. What are those? That is because of that condition. What is happening? Number of exhaustive events are reduced. Clear? Next. So okay or not?
Yes, sir.
Right, next question related with the same dice, but with a different kind of application. Then you have to say whether they are equally likely events or not. That is also very important. Right now. A dice is considered such that the probability of happening exercise exercise with n dots on a side with the n dots. Probability of happening exercise with the n dots. N, small n dots is proportional to n. Is proportional then what is the probability of getting a side? What is the probability of getting a side with the three dots? What is the problem? You are not writing. What's the problem? Then what is the probability of getting a side with the three dots? Three dots. Yeah, three dots. Yes. Probability of getting three dots. What is probability of getting three dots? What is probability of getting three dots? Tell me now. Normally, what is probability of getting one dot? One. Remaining will not happen. That's the matter. Probability of getting not related to this. I'm generally asking. Actually, you will be having 1, 2, 3, 4, 5, 6. What is probability of getting one dot? 1 by 6. Probability of getting two dots? 1 by 6. Probability of getting three dots? That is for equally likely events. But here, the dice is considered such that. How it is considered? N dots. Probability of getting one dot is proportional to 1. Not 1 by 6. Probability of getting two dots proportional to 2. 6 dots proportional to 6. Okay. And the proportionality is given. What do you get right? Probability of getting n dots is equal to kn. Right now. The probability of getting one dot. Yes, please. K. Probability of getting two dots. 2k. Three dots. Everything you have right. 3k. Probability of getting four dots. Yes. 4k. Probability of getting five dots. Yes. 5k. Probability of getting six dots is equal to 6k. That is the thing given. Here the events are not equally likely. It is equally likely, everything is equal to 1 by 6, 1 by 6, 1 by 6, 1 by 6. It is not given like that. It's a different kind of problem. The condition is given in that problem itself. Okay. You know one important thing, what about sum of all problems, any exponent, P of A plus P of not given A. Equal to, in any exponent, sum of all probabilities always equals to,
One.
come on. Explain the message. Any problem, sum of all probabilities is always equals to. Now you just sum all this. Sum all this. What is it? 21k must be equals to.
One.
What is k now? K equals to 1 by 21. So what is probability of getting 3 dots? Is equal to 3 by 1 by 0 point. Very fast. 0 point. Give the appreciation at least. How many they have given? You are clapping again. So more encouragement. The probability of getting 3 dots is 1 by is equally likely events. Yes. Association award will be taken back. You continue. You continuously do speak. No, wait, make it fast. Yes, what's the doubt? Come on, maybe. Maybe suppose after that we take the other way and never put it. Okay, sir. Different kinds of problems in I solve. So dice మీద ఇంకా సింపుల్ వి ఉన్నాయి. But whenever we find the time, just for the some kind of important practices or like important problem practices, either online or offline, we will do them like that. And let us continue with one more different type of. Right on next. What is the probability? What is the probability that a divisor of 10 power 99 is a multiple of 10 power 96. A divisor of 10 power 99 is a multiple of 10 power
99.
the multiple of 10 power 96. So here we have to find all the divisors of 10 power 99. What is the meaning of divisor? The number which divides that one with the zero remainder is a divisor. You have to count all such divisors for 10 power 90. In order to find the divisors, write this space 10 as a product of prime numbers. Okay, 10 power 99 can be written as 2 power 99 into 5 power 99. 2 is prime number, 5 is prime number. 1 is negative prime,
No.
you cannot write 1 there. If 12 is there, then 12 is there. What are 5 multiples of it? 2 into 2 into 3. So 2 power 99, 2 power 99 and 3 power 90. Okay. In such a manner, you have to write. Now, this I am writing it as in order to calculate all possible divisors. I am writing this as 2 power a into 5 power a. Sorry, 5 power b. Another one. 2 power a into 5 power b. Now, what are all and what are all possibilities for b? In place of a, you can write any number from 0 to 90. Here, a can be taken up to 99, starting with 0. Okay? Multiplication is there. And for 5 power b, again b can be taken from 0 to 99. A can be taken from 0 to 99, B can be taken from 0 to 99. So clear? Now let us check. Listen. In place of A, B, if I have taken 0, 0, 2, 4, 0, 1, 5, 4, 0, 1. 1 is a divisor of that number. Say yes or no. If you take A as 0, B as 1, 2, 4, 0, 1 into 5. 5 is divisor or not? 5 divides this number with 0 reminder. Clear? If A1, B1, 2 power 1, 5 power 1, 10. 10 divides that one or not? So all possibilities are there. Now you tell me, how many divisors are there? How many? How many for A? I expected 19. What about 0? Huh? How many? 100. What? And means multiplication. Again for B, 100. How many possibilities? 10,000 possibilities. For A and B. Divisors of 10 power 99. Right? Among those 10 power, 10,000 divisors, some of them are multiples of 10 power 96. So, how to calculate 10 power 96 multiples? 10 power 99 can be written as 10 power 96 into 10 power 3. Now 10 3 can be written as 2 power a1 into 5 power b1. What are possibilities for a1? 0 less than or equal to a1 less than or equal to 3. And what are possibilities for b1? 0 less than equal to b1 less than equal to 3. So you tell me now. What are favorable? 1000 divisors. There are some multiples of 10 power 96. How many multiples are there? All possibilities for 10 cube are also divisors. How many? For A1, 4. For B1, 4 and 4. What is the meaning? 4 into 4. This is done. It's okay. Clear? Not done. Now. Okay. So actually in aptitude, general aptitude, you will be having this kind of questions. But here, along with that general aptitude, we are doing the application of probability. Probability means total number of favorable events divided by total number of the same events. Okay, total number of favorable events divided by total number of exhaustive events. Okay, so these are some of the different kinds of problems only on the definition. Now we need to know about addition theorem on probability. Right? Addition theorem on probability. Addition theorem on probability. See here, in addition theorem on probability, listen, the events are going to occur in only one tribe. One tribe. For multiplication theorem or dependent independent events, events may occur in 2 or 3 or 4 or many tribes. But here, in addition theorem on probability, events are going to occur in only one tribe. Okay. So here we have to consider mutual exclusiveness, not mutually exclusive. Two things, but in one tribe. You need to observe those two in one tribe. Clear? Right now. If A comma B are two mutually exclusive events. Two mutually exclusive events with their happening probabilities. With their happening probabilities. P of A comma P of B. P of A comma P of B. Okay. Mutual exclusive means, is it possible to happen both the events at the same time? Okay. Is it possible to get a birth for baby boy and girl in the same person? It's scientifically wrong. Okay. So therefore, they are purely mutually exclusive events. If head comes up, is it possible to get the tail again at the same time? Both head and tail at the same time? No. So they are purely mutually exclusive. If you are one is getting gold medal in a running race, the second person also is able to get the gold medal. All the people are able to get the gold medal. So they are mutually exclusive, right? So in this case, the probability of happening either A or B. Happening either A or B. As a result of one tribe. As a result of one tribe is denoted by P of A union B and equals to P of A plus. That's enough. There is no question of getting both at the same time. Okay. Either A or B in one stride. In one stride. A and B are mutually exclusive. So tell me an event which is not mutually exclusive. A is the event of getting sun. S-U-N. Not S-O-N. Okay, A is the event of getting sun. B is the event of getting rain. C is the event of getting rain. Okay, tell me now. Tell me now. Both are mutually exclusive or not exclusive? Why? Speak up, tell me, explain. Yes. It's what's happening there? ఏంటి మీరేదో చాలా అంతర్జాతీయ సమస్య మీద డిస్కస్ చేస్తున్నారు. ఇజ్రాయెల్, లెబనాన్, ఇంకా ఇంకేంటమ్మా పర్లేదు లేవు చెప్పండి ఇబ్బంది ఏదో ఆగిపోయిందా ఆగలేదా బాగా వస్తే కాదు మీ ఇద్దరు అని చెప్తారు లేదా ఇద్దరే లేదా అది చెప్పాల్సిన ఏమిటాయి రైట్ ఏ మీద ఏంటా ఏంటమ్మా ఇంకా అర్థం కాలేదా సమస్య మీదే మీ సమస్యను మీరు ఇతరులకు చెప్పలేకపోతున్నారు A be the event of getting sun, B be the event of getting rain. Both are. Is there any possibility of getting both at the same time? Yes, there is possibility of happening both at the same time. So they are mutually not exclusive. In such a case, both are happening at the same time. So then, write down. If A comma B are, if A comma B are not mutually exclusive, not mutually exclusive, then the probability of happening, either A or B. Either A or B. As a result of one trial. As a result of one trial. As a result of one trial is P of A union B equals to P of A plus minus P of A intersection. What is P of A intersection B? The probability of happening both at the same time. Okay, if you want to just write it. Where P of A intersection B is, where P of A intersection B is, the probability of happening, both A and B at the same time. At the same time. Okay, this is for mutual exclusive and this is for not mutually exclusive. In the examination, they won't be given. In the question, they will not ask you, or they will not give you. They are mutually exclusive, they are not mutually exclusive. You have to identify. You need to You need to observe it, whether they are mutually exclusive or not. Let us go ahead with the problem, right? In a horse race, horse race, the odds in favor of 4 horses, odds, ODDS. Odds in favor of 4 horses. H1, H2, H3, H4 are respectively given as R, RER, respectively given as respectively given as 1 to 4, 1 to 5, 1 to 6, 1 to 7, 1 to 7, 1 to 4, 1 to 5, 1 to 6, and then 1 to 7. 1 to 7. Assuming that a dead heat is not possible. Assuming that a dead heat is not possible. Is not possible. Find the chance that one of the horse wins the race. Find the chance that one of the horse wins the race. Okay. So we have 4 horses. Their odds in favor of 4 horses. So given like this. Okay. Next, we have given dead heat is not possible. Then we need to write one of the horse wins the race. Okay. What is the meaning of dead heat? Huh? What is the meaning of dead heat? Is it the temperature which makes the horse dead? Yes? Oh. Then what is dead heat? See here, heat means if 100 candidates are participating in 100-meter race, if 100 candidates are participating 100-meter race, then you need 100 tracks. Huh? Have you observed 100 tracks in a single ground? 100 tracks. How many? Mostly 10 or 12, not more than. Okay. All those 100 people are going to be divided into 10 groups. They will conduct an event. Event 1, event 2, event 3, up to event 10. Okay. The event 1 to event 10. Those events are called as heats. It's not the temperature which makes the horse dead. They are nothing but events. Heats means they are events. Okay. Dead heat means if 2 or more than 2 horses cross the same distance in quickest time. If 2 or more horses cross the same distance in quickest time, then what will consider? Huh? The organizer has to give the prize money to all the people who bet their money on those 2 horses. Am I right? If all the horses cross the same distance in the same time, now what they have to do? If all the horses cross the same distance in quickest time or same time, what the organizer has to give? He has to give the prize money to all the people who bet their money on all those horses. There will be only 10 horses or 5 horses, but how many people are betting their money on those 50,000? The organizer has to give double the amount which those people have bet on those horses. Is it possible? The organizer has to shut everything and he has to commit suicide. Am I right or not? It is not possible. It is not possible. Even if 2 horses cross the same distance in quickest time, the organizer will cancel the event. Okay, because it is a non-profitable business. It will be a great loss to him. That's why he will cancel that. So what is valid event? Only one has to win. The remaining has to speak up. Only one has to win. The remaining has to lose. That's enough simple. Dead heat means 2 or more than crossing the same distance in quickest time. That is not possible. That means only one has to win, the remaining has to lose. So one is winning, remaining or losing means what type of events these are? Mutually exclusive or not exclusive? Mutually exclusive. Happening of one prevents the happening of all given. Okay, in election, in an assembly constituency, 100 people will contest. 100 people will contest. Only one will win. Okay, in Olympics, in 100 meters race, 100 people may contest. Only one will get gold medal. Winning of one person and losing all the remaining. These are mutually exclusive events. So what kind of events these are now? Mutually exclusive events. Okay, right. Actually, that word is not given. You have to understand what is delegate, what is state. Right now. As delegate is not possible, as delegate is not possible. Delegate is not possible. Not possible. Only one will mix the race. Only one will mix the race. And the remaining will lose the race. So here the events are mutually exclusive events. Events are mutually exclusive events. So probability that one of the horse wins the race. Right? Probability that one of the horse wins the race is P of H1 union, H2 union, H3 union, H4. Okay. What is the meaning? Either H1 or H2 or H3 or H4. Okay, that equals to their mutual exclusive. What is the formula? P of H1 plus P of H2 plus P of H3 plus P of H4.